All right, guys, we are back. Up next, we're going to be talking about execution sharding through native rollups with a real heartbreaker from L2BEAT, Luca.
Thank you. So hey, everyone. I'm Luca. I'm head of research at L2BEAT, and I'm also leading the native rollups effort. And I want to talk today about execution sharding. I'm sure that some of you might have some PTSD when they hear the word sharding. But, you know, it's interesting stuff, and it might be time to talk about that in the Ethereum space. So I already gave a couple of presentations about native rollups in the past. One at Bankless Summit in Buenos Aires, which was kind of high level and motivational on why we're doing this. I gave another one at DevConnect in Buenos Aires. At ETHProofs Day, it was a bit more technical. So I already talked about native rollups quite a bit. So today I wanted to try something a little bit different. I wanted to kind of explain native rollups through the lens of execution sharding by presenting a comparison between the sharding approaches of two other ecosystems, in this case, Near and Polkadot, because these are two blockchains that on production already have sharding, and Ethereum doesn't, right? So in particular, I've analyzed Nightshade 2.0, which is the sharding protocol by Near. I've been reading quite a bit the wiki from Polkadot, and from the Ethereum side, we have the rollups and the native rollups, which I'm working on. And also one reason I'm doing this is because I feel like we should spend more time as an ecosystem looking at other ecosystems instead of just seeing them as competitors, because they're building cool stuff and this stuff is cool. And disclaimer, I'm very familiar with Ethereum, I'm very familiar with L2s, I'm less familiar about these ecosystems. So I spent some time reading about them. I'm sure I will say something wrong, but hopefully it's not too far. And also one motivation of why I'm giving this speech is because when I made this tweet about the native rollups UAP, Polkadot retweeted saying, "Hello, Polkadot 2020." So I kind of felt like this talk is a bit unfair because I'm talking about Ethereum future stuff that we'll implement while comparing it to stuff that is already in production. But since Polkadot made this tweet, I kind of feel justified to do it anyway. So what is sharding? Sharding, at least in the blockchain context, is born from the idea that nodes should not all perform the same tasks, but with guarantees as close as possible as if they do. So today in blockchains, all nodes do the same thing. Why do they do the same thing? For a good reason, because we want to give them all the same security, right? We want all of them to keep up with the chain, execute transaction, maintain the state, and so on. But the thing is that, of course, this is inefficient. So if you can do better, if you can shard these roles so that some nodes can do less with the same guarantees, that would be better. There are three main tasks that nodes perform in a blockchain. They execute transactions. And they execute transactions because they know they need to validate that blocks are valid, right? Nodes maintain the state, because if a transaction touches a piece of state, they need to know what is the state, what are the values, so they need to be able to read the state, and they participate in consensus. So we might think about sharding, these three things, but consensus in particular is the thing that you don't want to shard. Consensus is one of those things that the more nodes you have that participate, the more economic security you have within a single network, the better. And all these three blockchains, Near, Polkadot, and Ethereum, and others, do agree in this. In the sense, we want to have multiple execution environments, but we want them to share the same consensus. The stronger the consensus is, the better. There is actually one ecosystem that disagrees with this, which is Cosmos. They have all different chains with their own consensus. Which arguably is bad because it becomes easier to compromise one single chain. Because again, everyone has their own consensus. There is this famous example of Chihuahua chain in Cosmos that has a few tens of thousands of economic security, which is supposedly easy to compromise if you want to try. But yeah, consensus is the thing that you don't want to shard. One thing that you can shard is state. And this is feasible. Like both Near and Polkadot already do this. Not every node maintains the state because they have stateless execution. We tried to do this in Ethereum. We're still trying. It's difficult for many reasons. There is a conference in ETHCC in Cannes, if you want to attend, regarding stateless in Ethereum. But like this is possible. And the idea here is a node doesn't maintain its own state. If it wants to execute a transaction, I will also give the node the information about the state. And the node can verify that this state is correct with a Merkle proof or a Merkle proof or whatever against a root. So this is feasible. Sharding transaction execution is the difficult part. Like both in Near and Polkadot, nodes either execute transactions or don't, and the ones that don't do not have validity guarantees of those transactions. But I'm going to talk about this. But the thing that I want to keep in mind is that sharding execution is hard. So what happens is Near. Near has 9 shards. They call them chunks. And they call them chunks because they're all synchronized, they all have the same block times, they're all identical. They have the same state transition function, they do all the same things. Block producers are chosen among validators, which means they're picked, they're elected, they have some time to download the state, because if you're a block producer, you need to have the state. And then they produce the state transition with the stateless execution, they send it around, and node need to re-execute. But the thing is that not all nodes re-execute. So Near today has 384 validators, and in each chunk, there are 105 mandates. And a mandate is a certain amount of Near tokens. And if you're a validator and you have more stake, you will get more mandates. So for example, one mandate is this 500K Near. The top validator usually gets 55 mandates. And for each chunk, you need 71 mandates to sign that the block is valid. If you reach 71, the block is considered valid by everyone in the network, right? So if you get 71 mandates that are malicious, like validators that that are malicious, that reach this threshold, the network will finalize an invalid block, and the other nodes will not notice even, because they're not executing, right? I did some math, given the current distribution, to reach 71 mandates. The median is 24 validators. So if you have 24 validators in the same committee, you might be compromised. The chain might be compromised. They do some math and they say, look, if we take the 1/3 threshold for BFT tolerance, and these are malicious, the chance that you get these malicious nodes within the same committee is like super low. They did the math with 800 validators and 4 shards. They have less validators and more shards. If you actually do the math with the current distribution, the math is worse. Like they say, you will compromise the blockchain in 1 trillion billion years. If you do the math with the actual numbers, it's much worse. And the thing is that it is exponentially worse the more centralized stake is. Next is Polkadot. Polkadot has parachains. These are not all identical. They can be custom. You can have your own state transition that you can publish. This is very similar to Rollups. If you go to Wiki, the Polkadot Wiki, they're trying to rename parachains to Rollups, which is funny, but it is correct. They have custom governance. They have custom block production. You can define within the state transition function who can sequence. They call them, the sequencer are called collators in Polkadot, but they are sequencers. And they do something very similar to Near. So instead of having these 105 mandates, they do a first pass with very, very few validators, just a 2 out of 5 validators check. This is the first pass. So these 5 validators are elected. If 2 of them say the block is correct, then it goes through. So this is like super small set, but they are an improvement over Near in the sense that they have a dispute mechanism. So you can think about parachains in the same way that in Ethereum land we think about optimistic rollups. If there is someone that noticed that something is wrong, it can raise a dispute. And if there is a dispute, all nodes in the network need to re-execute to check whether the thing was correct or not. In practice, what happens in the happy case is that there is this first pass with a 2 out of 5. Then you need these checkers that are, you need the 30 confirmations, like you pick at random 30 validators. They need to re-execute using stateless execution. And if they confirm, the block gets included and it gets finalized. So also here, you have a risk whether these 30 validators that are elected are malicious and they all confirm, even though the block is invalid. But again, it is an improvement of a linear in the form of we have a dispute mechanism so that if someone notices that something is wrong, they can raise the dispute on chain, everyone sees the dispute, and everyone needs to re-execute. Actually, in the near white paper, they mention this approach, and they say, we know that this approach exists, and we decided not to implement this because it adds a lot of complexity, and it might not be worth it, which is understandable, also because these disputes created problems in Polkadot. So in 2023, they had what is called the dispute storm. Basically, they had an upgrade, and a node didn't upgrade, or at least they did upgrade their node, but they didn't restart the node, so they were using the old state transition function. And it started launching disputes at all the blocks, because for its perspective, all the blocks were invalid. And this caused loss of finality. It took, if you read, 12 hours to recover the network. The network was overloaded. So this happened again in 2025 for the same reason, more or less. Some nodes didn't upgrade. But what I'm trying to say is, in blockchains, regarding validity, and even in near, right? They did the math saying, we use the BFT threshold, which is 1/3, and we say, okay, what is the probability that validity is compromised if this amount of validators are compromised? Usually, today on Ethereum, the property that we get is that even if all validators in the network are compromised, are malicious, a node cannot be convinced that an invalid block is valid, because the node will re-execute. So even if 100 validators are malicious, you will not fool a node with an invalid state transition. And Polkadot understands this, I'm sure, and that's why they introduced disputes. Because they don't want to have this issue that potentially near has, where a minority can compromise validity of a network. But if the thing is, they want to get the same guarantees, but given the dispute mechanism, if just one node or few nodes don't upgrade, you get these issues, right? They did some improvements, of course, so I'm sure that this is not such a big deal. But in any case, this is stuff that adds complexity, and we know also optimistic rollups have a lot of problems. I gave a talk in the past in Bangkok about this. What about Ethereum? So Ethereum, they call them rollups. They're custom. We have many rollups. You can do whatever you want with them. They have custom block production. Everyone has its own sequencers. And they can either use custom or native governance. So custom is what happens today. Everyone can upgrade. They have some DAOs or some multisigs that can upgrade. Native governance is what native rollups would introduce. And the idea here is we have L1 with its own EVM, and the L1 will move to ZK, and we can convince, we can expose the ZK's infrastructure to the rollups themselves so that they use the same state transition function. If L1 upgrades, the L2 will also upgrade automatically without having to have a custom governance. So that's kind of what native rollup means. And the difference between what Ethereum is trying to achieve with these rollups and native rollups compared to the others is that we want to maintain the feature that everyone validates all the transactions in all the rollups, in all these shards. While the others, all these certain nodes are convinced about the validity of the network, we want everyone to do so. And we have over 900,000 validators, so this is a really big task. What is the trade-off? The trade-off is ZK proofs are super complicated. They're very complicated, they're buggy, and that's also, it's a trade-off that we need to be careful about. But this is super exciting. We would be able to maintain the property of you will never be able to convince a node about a malicious state transition function. I don't have time for this slide. This is the work that I'm doing on native rollups. Scan the QR code if you're interested in what's coming. Thank you.